Thank you very much, Andrea. I hope everybody can hear me. I will provide a presentation, but let me first of all say I'm very honored and pleased to be part of this big virtual conference. More than 1,000 people have subscribed to it. Probably this would have not been possible if we would do it in a physical, analogous way, so to speak. Let me tell you why I became acquainted with this whole topic also, which in the end is about constructing our cities, our buildings, our infrastructures with organic materials. So the title of my talk is Reforesting the Planet and Retimbering the City. So these are the two sides of the coin which are really important. So let me start really with climate change, the big emergency we are in that Andrea has already mentioned. So let me see. My first slide is about the Paris Agreement. And I will try to explain to you now why the Paris Agreement was choosing certain critical thresholds where we want to stop global warming. In particular, we want to keep global warming well below 2 degrees, but even we are aiming at stopping global warming at 1.5 degrees. What is the scientific justification for that? Well, it all has to do with this map, which I, for the first time, introduced at a lecture I think I gave in the year 2001 at the University of Oxford. It's about the so-called tipping elements in the Earth system. These are the vital organs of our global environment. So you have the circulation patterns in the ocean, like the Gulf Stream or the jet stream in the atmosphere. You have the big ecosystems like the Great Barrier Reef, the coral reefs, the Amazon rainforest, of course, and you have the monsoon systems, but you have in particular the big ice sheets. And you know, if the ice sheets melt down, sea level will rise by up to 70 meters, 70 meters. So all the coastlines, or most of the coastlines of the present world, would be completely transformed. And in order to illustrate that, one very fragile ice sheet is the Greenland ice sheet. And I just showed to you that in the year 2019, we had a record melt of the Greenland ice sheet, 1 million tons of ice per minute. You have to imagine that. But let me show you also why this 1.5 to 2 degrees corridor has become important, actually crucial for multilateral conventions like the Paris Agreement. So this is a busy diagram. So just focus on the right-hand side on the cluster. It's called large-scale singular events, terminology actually I introduced in the IPCC in the year 2001, the third assessment report. And this is precisely about crossing tipping points. For example, crossing the line where the Greenland ice sheet will melt down in an irreversible way. And that would add 7 meters to global sea level, actually. And what you see is how our evidence progressed over the time. So on the right-hand cluster, if you look at the first column on the left, third assessment report 2001, we thought that all these critical events like melting of the ice sheet would happen at 5 to 6 degrees warming. You see, it's a color coding telling you that if it's deep red, we are sure that tipping will happen. And if it's light yellow, we are a little bit concerned only. But now see how the color has gone down, actually, has flown down. On the right-hand side, you see the special report of the IPCC 2018, where you now see that we expect tipping points to be crossed between 1 degree and 2.5 degrees already. And if you now look at the corridor defined by the Paris Agreement, you see it's like a firewall that is separating our world from these very, very bad, actually devastating outcomes. That's why the Paris Agreement was choosing the right temperature targets. So this is the ultimate scientific justification for the Paris Agreement. I've showed you this slide already. Now, we obviously need to decarbonize our global economy by 2050 at the latest. But in the policy discourses, one important aspect has been neglected all the time. That is what we call the biosphere carbon sinks, or the carbon sinks in general. Because even if we decarbonize our industry by 2050 and private households and everything, this will not be enough in order to stop global warming at 2 degrees, let alone 1.5 degrees. What we need to do is first protect the natural carbon sinks, that is in particular the forest, the tropical forest and so on, stop deforestation on this planet, but then add another carbon sink, which means we can extract carbon from the atmosphere again. And where is the perfect solution? That is timber construction. So even I have not realized for a long time the elephant in the climate room, which you see here in an illustrative way, the big elephant, which consists of the built environment, of course, and churning out lots and lots of CO2. Now, with timber construction, we cannot only avoid that, as the President Ursula von der Leyen has mentioned in a video before, we can actually undo some of the past emissions. So it's almost like a silver bullet. But just to give you the order of magnitude, the scale of the challenge, about 40% of global greenhouse gas emissions are emanated from the built environment, either by building or operating edifices. And even more, about 55% of the waste emerging in developed countries is coming from construction and demolition of buildings. So it's really a big, big contribution. So why can we not avoid actually emissions from building with concrete and steel? Well, these are simply chemical reactions which are associated with iron smelting on the left-hand side or lime burning on the right-hand side. You simply cannot avoid it. It's the laws of chemistry, actually. But we can do much, much better, and we have thought about this. So we published an analysis that was developed over several years, recently last year in a top journal, Nature Sustainability. It's called Buildings as a Global Carbon Sink. And just for demonstration, just for illustration, I show you now how you can reverse the emissions from the construction sector and turn it into carbon sequestration, actually. So we did a thought experiment here. So we thought about another 2 billion people who will arrive on this planet, will be born and have to be accommodated. And if you would actually accommodate them with a mixture of buildings, 90% erected with steel and concrete and only 10% wood contribution, when you would see on the right-hand side that about 70 gigatons of CO2 would be emitted. And wood would actually store a little bit through photosynthesis and sequestration in buildings, would tuck away at least 0.4 gigatons of carbon. But if you would do the opposite, actually, you would use 90% of timber in the construction for housing of these 2 billion additional people on Earth, when you would reduce the emissions of concrete and steel to 1/10 actually, but you would store a huge amount of carbon by the timber construction. That means about 130 gigatons of carbon would be saved this way. And this is really a significant contribution to stabilizing the world's climate at the level the Paris Agreement is stipulating. Yeah? Now, the big construction and the big idea behind all that is what I call the forestry construction pump. That means you first look at quasi-equilibrium. You know, you have stable forests, you have no fossil fuel burning, then you have almost an equilibrium between atmospheric CO2 through photosynthesis. This is turned into biomass in the forest. A little bit of that goes into the soil. We call that humidification. But when the trees are rotten down by natural processes, you have remineralization and it goes back to the atmosphere. But actually now we are in a completely different situation. Namely, we have here lots of fossil energy sources, combustion, atmospheric CO2 is added. So still there's photosynthesis, mineralization, humidification, but CO2 concentration in the atmosphere keeps rising and rising. Now, what we could do is, if you log the forest, produce timber, turn it into construction in a built environment, recycle most of the wood, which you can do up to 90% at least. You have cascading utilization, but immediately replant the trees, which you have taken away, and maybe even increase the forest area. When you do have something what I call the forestry construction pump, you could do this every 30 years or even 25 years if you have fast-growing trees. And if you do this for 4 or 5 times within a century or 120 years, you could not only undo and stop the emissions from the construction area, now you could even extract net carbon from the atmosphere. And you can see this, you would have a net flow of carbon from fossil energy sources into the built environment. So in a way, we would do something like a geoengineering experiment, but with only natural solutions involved. So it's the perfect formula, actually. Now, in order to do this in a realistic way, we have to now embrace a crucial research agenda. First of all, we have to stop deforestation. What are the policy options for that? What is the potential of afforestation, reforestation worldwide? When we have to look for sustainable timber production, which would even work under the conditions of the Paris Agreement, that means our world will warm by something like 2 degrees. That is a major challenge for forestry. We have to come up with a new type of forestry. When the question is, how much timber can we reuse by construction, renovation, utilization? What is the resulting carbon extraction and sequestration? How many ppm of CO2 in the atmosphere can we undo actually? And finally, you have to do a cost-benefit analysis. And you have to ask, what are the regimes, the policy regimes needed? For example, liberalization of building codes and things like that, or even incentive through a carbon certificate system. So that's a crucial agenda. Let me not just show you that currently we are doing precisely the wrong thing. We have loss of forest cover worldwide, in particular in the tropics, because of slash and burn economy, things like that. The Amazon rainforest may actually enter a tipping point where it turns into savanna very soon. Can it be undone? That is the first thing. Yes, the Chinese have demonstrated that. If you look at the left-hand side, that's the last plateau in China, 2007, and you see only 12 years later that you see green landscapes again. That is done actually in no time at all. And there is now a very ambitious scheme, which has been proposed by a group called the Weather Makers. Whether this is only a dream, I don't know yet, but what you see is the Sinai Peninsula. And on the left-hand side, you see how it looks today. But if you look closely on the left-hand side, you see patterns of past rivers, actually, river system. So the idea is to turn the Sinai into, again, a forested area with appropriate schemes. And as I said, 6,000 years ago, this was a green landscape. It could be done again, and the same could be done in the Sahel, in India, in many places on this planet. So the first part of my slogan, reforest the planet, that's it. And when turn it into sort of built forest, cities that consist of timber, I would like to draw your attention to two excellent books written by Pablo van der Lugt, who also provided me with some slides. It's about timber and bamboo, actually, which is a very important material, because if you look here at the annual change in forest area, we have to distinguish between the northern hemisphere. You see where we mainly have increase in forest area, in particular China, through all types of management schemes, but we have loss of forest area in the tropics. Now, in the tropics, hardwood is probably not a very good material for timber construction, but we could use bamboo, and you know that within 5 or 6 years, bamboo is maturing. You can use it in various ways. There are modern ways to treat it. But in the northern hemisphere, fast-growing softwood is probably something which will be available in abundance. Now I'm coming back. The whole idea, the whole initiative of retimbering the cities of this world was boosted tremendously by Ursula von der Leyen's State of the Union speech last September, where she talked actually about building the world and rebuilding the world and creating a new European Bauhaus. Now, let me end with a few comments on this, because this was inspired by the original Bauhaus, which was established by Walter Gropius and a handful of supporters in 1919 in Weimar, in Germany. Later moved to Dessau and went to Berlin before the movement was crushed by the Nazis. And this was very important because the idea was to have what you call in German a Gesamtkunstwerk, a sort of a total piece of art where all the different disciplines work together. So artisans and painters and architects and designers and so on. We have to do this again. We have to break the mold of the various disciplines, but we have to meet the challenges of the 21st century. That's why you need a Bauhaus for the earth, for the entire earth, actually. And coming back, Ruth Reichstein will talk about this, but Ursula von der Leyen already mentioned it. It's about 3 keywords. The first one is sustainability, clearly. If we can store a lot of carbon by timber construction, that contributes clearly to global sustainability. The second is inclusiveness, that means creating more social cohesion. The third one is beautiful, actually, doing it in style, transforming the built environment in style. So just a few comments you have here, that current construction sector is actually very divisive. So you see luxury apartments on the right-hand side in a favela in Sao Paulo, and on the left-hand side you see how the poor people live. This is not okay, and the original Bauhaus actually tried to overcome social lines separating people. And when, of course, in this world, we will see more and more refugees, people on the move, migrants and so on. And a fantastic contribution was made by Shigeru Ban, the famous architect, winner of the Pritzker Prize, who created all types of sort of accommodations, even a church, a beautiful church, built from paper, for example, built from wood and so on. This is the new age of architecture, actually. And I'm very glad to say that Shigeru Ban has joined a high-level advisory group for Ursula von der Leyen for the new European Bauhaus, where I'm also a member, so we will meet many times in the future, which is wonderful. So finally, when we talk about social cohesion, many of you may have been or have seen pictures of Siena in Tuscany, You see pictures of the patio. And this was, a community piece of art, actually building this centerpiece, including the cathedral here. All citizens of Siena tried to contribute to that. So you can create beautiful architecture, but you can do it in a communitarian way, actually, co-producing, co-creating beautiful, sustainable, and inclusive structures. That's the plan of the new European Bauhaus. And the final note is, this is not technology of the past. Today, in particular, if you use organic materials, you need high tech, actually. You need to combine no tech, that means natural materials, with high tech, including artificial intelligence. Just leave you with this hint here, a nice paper written in Scientific American about a new way of densifying wood. And you can even have bulletproof construction by this. It's amazing what you can do with this organic material, but it's not a surprise because it took natural evolution 500 million years to optimize a material we call wood. So all in all, this is about innovation, really. So I'll stop here and I thank you for your attention.
Thank you very much for this great presentation and talk, encouraging words. We have a few questions from the audience already, and maybe first would be, since we are all passionate about the wood here gathered, so how much could more wood or timber construction and using more harvested wood products in the buildings, furniture, or any other application contribute to reduce the global warming?
I mean, first of all, as I said, it's a supply and demand issue, clearly. Yeah? I mean, currently the demand for timber construction is still very low. Although in Germany, for example, one-story buildings or one-family homes or two-family homes are already sort of making 20% of the market. But this needs to be increased in particular multiple-story buildings, 4, 5, 6 stories, or even skyscrapers you can build from wood. But the demand has to be increased, and this has to do with regulation very often, national regulation. I think the European Union could make here a major contribution by asking for much more liberal and fairer boundary conditions for wood construction. And the other question clearly is, do we have enough timber? The irony is that global warming will actually, and climate change, is increasing the supply of wood in principle if you have the right management technologies of our forest, because, for example, CO2, if there's plenty of CO2 or even more CO2 in the atmosphere, this is actually fertilizing the forests. Of course, on the other hand, you have invasion of species, you have droughts, you have storms and so on. But if you do the right type of forest management, we will have actually more supply of timber. Now, if you calculate all in all, back of an envelope calculation, we think that about 30% of the global emissions could be compensated by timber construction. And that's a big contribution to the climate equation.
Yeah, thank you. So maybe a follow-up question would be if the policymakers have the open ears to the idea of large-scale reforestation programs.
I mean, this is, in principle, I think reforestation of degraded land in particular, not so much in Europe, but even in Europe, if you look around the Mediterranean, there are plenty of areas where you could do it in Greece, in Italy, in Spain, for example. I think on other continents, this is something every policymaker should be interested in. Reforestation I think, is a no regret option, clearly. Yeah? Because as you have seen the pictures from the Loess Plateau in China, you can actually create new biodiversity there. The big question, a very heated debate, is, of course, what do we do with the existing forests? So some people, in particular environmentalists, are a bit nervous whether if you use the forest for timber production, when would this be at odds with the biodiversity strategy also in Europe and worldwide? And there you simply have to notify that 95% of the forest areas in Germany, for example, are managed forests anyway that have been used for timber production or other things for a long time. So we are not talking about the hotspots of biodiversity worldwide. They need to be protected by all means, of course. But all the managed forests and the degraded land you can reforest. So I think a global initiative on reforesting areas which are actually suited for that is part of the climate solution.
And how can this be linked with the renovation and building with wood, the reforestation programs, I mean?
Yeah. No, I mean, you are mentioning a very important word and notion, that is renovation also. I mean, if you look at developed countries, you will not build so many new buildings, of course. No? So architects sometimes say Germany or France have been constructed already, but you need to renovate clearly. And if you want to provide more cheap, affordable accommodation, very often you can renovate, you can even add top stories if you use light material. And again, wood clearly has an advantage here, right? It's simply not as heavy as concrete and steel. But there are many ways. You can have parking lots, you can add a story above that. There are many schemes and demonstration projects already. So renovation clearly is very important. There is the European renovation wave. Here again, organic material would play a very, very important role.
And we, being in the business of timber construction, we know exactly that there needs to be somehow a change in the perception of people. And would you have a suggestion for us, the sector, how we can be efficient in our communication and persuading the society that timber can actually provide us shelter, healthy environment, as well as also safety in terms of earthquake or any other potential dangers?
Now, I think now with the European Commission and Ursula von der Leyen engaging in this, you have a golden opportunity, actually, because this is the narrative you have needed for a long time. Because in the end, it's very easy to convey the message with organic materials, because everybody loves wooden buildings or wooden floors or whatever. So there is the immediate sympathy for that. What one needs to demonstrate that it is affordable. But again, unlike with renewable energies 40 years ago, where photovoltaics was thousands of percent more expensive than power from coal sort of fired stations, for example, you are already almost at the same level of cost as concrete and steel construction is. So it takes only 10-20% of reduction, maybe through economy of scale, through new technologies, through incentives. So then you can provide accommodation at the same or even lower level of cost than conventional construction. So that's the one thing. And now with the new European Bauhaus, and Ruth Reichstein will talk about it, there's now a very, very compelling and attractive narrative. What you should do is you should support this initiative by the European Commission. And maybe the second suggestion is what I learned while giving lectures at various meetings of the construction sector, the timber construction sector, This seems to be a very fragmented community, which is not really well organized so far, unlike other conventional industries. I think it's time that you get your acts together and that you reorganize yourself, you speak with one voice, and you talk to the politician and civil society and spread the word about it.
And thank you for the encouragement. But at the same time, probably it's appropriate to ask you, what do you think is the main challenge for the timber sector to be enabling a bigger use of timber in the built environment, also in the cities?
The first problem clearly is regulation, the building codes and so on. It seems that in Europe, after the Great Fire of London in 1666, that is quite a while ago, people just thought it's too dangerous to build from timber, and other ways, stone and concrete and steel, are safer. That's not true anymore, but people don't know about it. But you can build in a very fire-safe way from timber. So what's the one thing? So the building codes have to be changed clearly. And so that means one needs to enter a very close discussion with the policymakers in the various nations, but also at the European level. That's extremely important. So the legislation so far is not in your favor, but it can be possible, it will be possible to create a level playing field where all construction approaches have the same chances. So that's very important. I think that can be done over the next 5 years or so already. That's very important. And the other thing, I mentioned this very quickly, and this is not grinding my own axe, it's really important. I think research in the cost, the supply, the demand, the technologies involved, in particular how digitalization helps you, research is very poor still. We need to move into a very, very important, a very crucial, a very fast research agenda on that. So I think the timber construction sector in Europe should support actually new research initiatives on that. So that in the next 5 or 8 years, we know precisely what the potential really is and how quickly we can speed up timber construction, and make it scalable actually. Because in the end, the vision is that in 100 years from now, concrete will be more or less a material of the past, actually, and we will build almost everything with, on the one hand, organic material, and with very advanced materials like carbon fiber, for example.
Thank you very much. We will get back to you with questions after our next speaker, which is my great pleasure.